We're now going to study Chapter 3, which is an entire chapter dedicated to just quadratic functions. Okay, whenever it says quadratic, that means x squared. So we're going to be dealing with parabolas. All right, there's three forms the quadratic function can be in. Standard form, f of x equals, anytime it's standard, it goes in descending order. Ax squared plus bx plus c. When it's in this form, you can find the y-intercept very easily. You can factor it. You can do lots of stuff. Vertex form, rather, is even better, and this is the one that you've been dealing with. So here's what vertex form looks like. F of x equals, there's an a number out in front, which would be the vertical stretch or shrink, x minus h quantity squared plus k. This form is great for graphing because we would go h units to the right and k units up. So if you go h to the right and k up, you find yourself at the vertex of the parabola. So the vertex is h comma k. The axis of symmetry, whenever you have a parabola, you can draw a line right down its middle, and so it's going to be a vertical line, x equals, and whatever that h number is. We'll do some examples so you can see what this is all talking about. Factored form, f of x equals, there's going to be the a factored out, and then there's x minus p and x minus q. And so when it's in factored form, the x-intercepts are very easy to state. One of the x-intercepts is going to be p comma 0, and the other one is q comma 0. Okay, so depending on what you want, you might have to get it into a particular form. Which one would be best for graphing? The best one for graphing is vertex form. Vertex form. Which one is easiest to state the y-intercept? To find a y-intercept, you put 0 for x. So here you have to put it in and do some calculating. Put a 0 in, do lots of calculating. Here, put 0 in for x. The y-intercept is c. The best one for the y-intercept is standard form. Of course, you can find the y-intercept with the other ones, just a little more work. And which one's easiest to state the x-intercept? That would be factored form. Factored form. So you might have to put a quadratic into the proper form to do what you need. Okay? Take a look at this first quadratic equation here. This parabola is a parabola opening up. Okay? But in order to graph it easily, we have to rearrange it and put it into vertex form. Okay? So what we're going to do is we're going to complete the square. And I will refresh with you the steps for doing that. So the first thing we're going to do is we're going to take that 2 out. So you're going to factor the 2 out of all the terms that have an x. So that leaves us with x squared. Factor the 2 out of 8, that's plus 4x. Okay, then you're going to leave some space. And you're not going to leave space for the 5. That poor 5, you're going to shove him off to the side. 5 does not get factored, okay, or part of this perfect trinomial that we're trying to make right here. The constant just gets shoved off. Okay, now here's the next step. You're going to take half of 4. So first you take that middle number there, you cut it in half, and then you square it. Half of 4 is 2, 2 squared is 4. So we're going to add a 4. Okay? So did I add a 4? Not really. Was this problem x squared? It's really 2x squared. And it's not really 4x, it's actually 8x. So how much did I just add? Well, it's kind of in disguise. It looks like plus 4, but that's actually plus 8. Okay, I just added 8 to this equation. Now you can't just add something to an equation and keep it the same. So down here at the end, in order to balance things out, since I just added 8, I'm going to subtract 8. Well, some people say they do stuff like this, but they add 8 again. So that would be if you're adding 8 to the right and to the left. I'm not doing right and left. I'm doing right and right again. So I'm going to add 8 to the right side and subtract 8 to the right side. I'm keeping all the numbers on one side because the f of x is on the other side. Okay, after you do that, The 2 outside is just your vertical stretch. This should be a perfect square trinomial. That means that it factors into something exactly 2 times the same thing, a quantity squared. And it's going to be x. This middle sign right here will tell you what to put. If it's a plus or minus, this one's going to be plus. And then you could square root that, or you could have that, and you get a 2. And then plus 5 minus 8 is going to be minus 3. Okay, so this is in vertex form. It's very easy to say the vertex. My parabola is going to go 2 units to the left, so that's negative 2. The parabola is going to go 3 units down. That's going to be negative 3. Okay, the parabola I know is going to be opening up. I'm going to draw the axis of symmetry before I write that. I will state the transformations now for you. Okay, so I see 1, 2, and 3 transformations. Number 1 is vertical stretch by 2. The second transformation is shift 2 units to the left. And the third transformation right there, I don't know what I'm doing, is 3 units down. Okay, at this point, it's just like last chapter. If you were successful in graphing a parabola, then after you do the algebra, everything's the same. So we're going to go 2 units to the left, 3 units down, and a vertical stretch of 2. So over 2, up 2, not 1. And not 3, but 3 times 2 is 6. Up 1, or up 2, up 6. Okay, that's about all we could fit. Here is the parabola. Okay, now whenever you draw a parabola, if it's opening up or down, there's always going to be an axis of symmetry. You can always draw a vertical line right down the center of the parabola. Okay, and that is the axis of symmetry. The axis of symmetry. Oh, it went through the vertex. Is it always going to go through the vertex? Yes, because the center of the parabola is that vertex. This is a vertical line. Okay, that's going to be a vux. So the axis of symmetry is x equals negative 2. Oh, look at that. There was a negative 2 there. Is the axis of symmetry number always going to match the x value of the vertex, the h value? And the answer is yes. It's always going to match that exactly. Okay, now completing the square might be rusty for a lot of people, so let's go ahead and officially write down all the steps. So this might be something helpful to have out as you're doing your assignment. Step 1, you have to get the x squared term alone. You have to get it alone. So what that means is you might have to factor out, but it's just from the x terms. You don't factor out from the constant. The constant gets shoved off to the side. Okay, the second step, once you got the x squared alone, is you half and square the b value. Half and square the b. And then you have to compensate. You have to compensate to balance things out. Okay, but when you're doing this, let's just pull a note here. Make sure you look for the disguise. Okay, the number might be in disguise, as in that last example that we did. And then the final step is to factor to put in vertex form. And the factoring should always be very easy because you should have made a perfect square trinomial. We're going to do this process again by looking at the steps and helping you with it. So taking a look at this next example here, step 1, get x squared alone. It's not alone. Okay, so we're going to have to factor out from these x terms, not the 1. So let's go ahead and factor out from these two things a negative 3. So parentheses, x squared is going to be alone. Positive 6 divided by negative 3 is negative 2x. Okay, leave some space. And where do we put that 1? Way down there. Okay, step 2, half and square the b value. So which one is the b value? Negative 2 right here, this middle term. So half of negative 2 is negative 1. Negative 2 cut in half and squared. If you want to do work, make sure you crawl up into the corner and do it. Negative 1 squared is positive 1, so I'm going to add a 1. Now, it says, make sure you compensate, but look out for the disguise. So is that actually plus 1? No, it's actually minus 3. So I just subtracted 3 from this side. And in order to balance things out, a minus 3 needs a plus 3. That's actually negative 3 in disguise. If you just added negative 3 to the equation, you better add a positive 3. So essentially, you change nothing about the equation. Okay, and the last step is to factor. So whatever a value you factored out in front is going to stay there. This is always going to be a quantity squared, and that's going to be plus 4. So let's talk about the factoring. It's always going to be x. That sign right there will tell you plus or minus. You could either half that, or you could square root of 1 to figure out 1. And there you go. The vertex is 1 to the right and 4 units up. Hey, without even seeing the graph yet, why don't we see if we can state the axis of symmetry? I know it's always going to be a vux, a vertical line, so it's x equals, and it's going to go through that h value. This graph opens down. Let's go draw the graph, and then we can talk about increasing, decreasing, and what's going on with it. So go 1 to the right, 4 up. And the graph's going to be opening down with a vertical stretch of 3. So over 1, down 3. It usually goes 1, 3, but it's not going to be 3. It's going to be negative 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. That is about all we're going to fit on this graph paper here. So the parabola is opening down. Vertical stretch of 3. I think I'm going to draw that axis of symmetry for fun. The axis of symmetry always goes right through the vertex, straight up and down. There it is. Always a vertical line. What's the domain of this parabola? What's the domain of all parabolas? They forever go left and right, so it's all reals. Now the range of parabola is going to vary. This parabola has a maximum and goes down, down, down. So starting at the smallest y value, negative infinity, and goes all the way up to positive 4 with brackets. Okay, where is he increasing? Where is he decreasing? There's no constant on a parabola. So there is going to be somewhere that he's increasing, and there is going to be somewhere that he's decreasing. So let's go look at this. Starting on the left-hand side, this parabola goes up, 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 and then down, 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 down. So he only has one section here. This section is increasing, and then this section here is decreasing. So he's increasing from negative infinity all the way up to, how do you state intervals of increasing to decreasing? Use x values. You state where the graph is increasing. At what x value does the graph go up? All the way to 1, I'll use brackets, and then starting at x value of 1, brackets, to infinity. It's like domain, but only the part for increasing, only the part for where does it go down. Like domain. All right, let's do another completing of the square. Step 1 is the x's alone. Nope, we're going to have to factor out a 2 there. So let's go ahead and write f of x equals, factor out a 2. X squared is now alone. Perfect. That's going to be plus 3x. Leave some space. And where do we put 1? We shove it way off to the side. Okay, this one is a little more interesting than the last one. We're going to take the b value. I'm going to crawl in the corner over here and do some work. I'm going to halve it, 3 halves, and square it. So 3 divided by 2 does not divide or simplify nicely. We're going to have to leave it as a fraction. Fractions are okay. They're just a top and a bottom. So can anyone tell me what the top squared is? Yeah, what'd you get? 9. And then the bottom has to get squared to make a 4. Okay, fractions are just tops and bottoms. So right here, I'm going to add 9/4. Is it always add? Like, what if this was negative? What if there was a negative and then I squared it? Isn't this always going to be plus? Okay, so how much did we just add to that equation? Don't forget about the disguise. We didn't add 9/4. We actually added 2 times 9/4. Let me go figure out what that is. 2 times 9/4. Okay, so we don't give the top and the bottom a 2. Let's put 2 over 1, just so it's not confusing. And we do not cross multiply. You multiply across the top and across the bottom. So if you said 18 over 4, yeah. But maybe instead of multiplying first and making huge numbers, I think I'm going to cancel the 2 with the 4 and make 1 over 2. So the answer is 9/2. If you got 18/4, I'd say great. Now please simplify that. So we just added, we added 9 over 2 in disguise. So if we just added 9 over 2, then let's compensate by subtracting 9 over 2. Okay. Same technique, same steps, but some fraction work. So let's go ahead and finish our factoring. It's going to be a quantity squared. It's going to be an x. That sign right there tells me plus. Okay, there's a couple ways you can figure this out. You can halve that, 3 over 2, or you could square root 9/4. What was 9/4 before he got squared? 3 over 2. Either way, it's 3 over 2. Do you like square rooting, or do you like halving? It's always the number over here in parentheses, too, if you have work on your paper. Here, I think I'm going to have to make a common denominator. Let's make common denominators of 2 over 2. So 2 over 2 minus 9 over 2 is going to be negative 7 over 2. So yes, I will expect you to be able to complete the square with fractions. It's the same work. You just might have to do a little bit of fractions on the side. The vertex is 3/2 to the left, negative 3/2, and 7/2 down, negative 7/2. The axis of symmetry, it's always going to be a vertical line. X equals that x value right there, negative 3/2. I didn't think it would be a good idea to graph this one, so this was just an algebra work problem. But you certainly could graph it. You go 1.5 to the left and 3/2 down, 3.5 down. Okay, let's take a look at writing some quadratic equations. Okay, remember, the vertex form, this is the one that we're going to use, very powerful. Vertex form, f of x equals a. Then the quantity x minus h squared plus a k. And the vertex is h comma k. Okay, determine the quadratic function. We're going to use this vertex form here. The vertex is 1, negative 3. So that tells us that h is 1 and k is negative 3. Okay, so maybe I should even put like some notes here. Okay, use vertex form. Use vertex form to do these. So let's write down the vertex. Let's hide the equation and let's practice again without looking. F of x equals, first comes the outer number, that vertical stretch shrink a. X minus h quantity squared plus k. Notice there's 1 minus sign and 1 plus sign, because minus actually means to the right, and that's to the up. Okay, so if it says the vertex is 1, negative 3, let's put 1 into the h spot, x minus 1, and let's put minus 3 into the k spot. How does this look so far? Does that look like the vertex? 1 to the right, 3 down? Good. Okay, now the second clue has the point 3, 5. Okay, kind of like Algebra 1 again. When I tell you about a point, that's just a random x, y. So we are going to need that to figure out our a value. This reminds me of when we do y equals mx plus b. We have to figure out the a value here. So let's put in a y number. Let's put 5 in right there. Give me an a. Just a. We don't know it yet. Give me an x. Let's use 3. 3 minus 1 squared minus 3. So just be careful with your work. Sometimes people lose the squared. That messes up all the calculations. Okay? So the first thing that we're going to do is inside parentheses, 3 minus 2, and we're going to make a 2. Quantity squared minus 3. Next thing I'll do is square this. So 2 times 2 is 4. So I think what I'll do is write 4a minus 3. Because if I wrote a4 minus 3, it looks a little weird. People might think that they can go ahead and subtract those. So that has the a next. So let's add 3 to both sides. 8 equals 4a. Divide by 4. A is a 2. Okay, now the direction said determine the quadratic function. So I need to actually write down my equation. I need to write down an f of x. So I had a pretty good answer here, but now that I know a is 2, I'm going to say 2 times the quantity x minus 1 squared minus 3. And what we're going to do is we're going to graph this parabola to check. So let's go 1 to the right, 3 down, opening up, vertical stretch of 2, over 1 up, 2, over 1 up, 6. Okay, that's good. Okay, do not veer out. After you hit that point, stay in this column. All right, now how do we check with the graph? I think this is the right quadratic equation. Let's go read this problem again. It said the vertex is 1, negative 3. Is that the vertex that we got? Yes. Okay, and it also said it was supposed to have the point 3, comma 5. Is the point 3, comma 5? Yes. Okay, this parabola, this equation checks. All right, so you can graphically check to see if the equation you designed has the qualities that it was asking for. All right, let's try one more. Determine the quadratic function. Okay, so first, without looking, can you write down the vertex form? Don't forget f of x equals, out in front you need an a value. If a is negative, that means it opens down. Okay, but you just put a, and then the algebra will work out the way it needs to. X minus h squared plus k. All right, when it says vertex, that's a fancy way of saying h and k. So let's go ahead and start our problem. Let's put the h number in. So it's going to be x minus 1 squared. And let's put k, and let's put minus 5. All right, so far so good. Now we still need to figure out the a. You have to calculate it with the clues they give you. You can't just guess. Now it says a y-intercept. Y-intercept. That's a point. That's the point. See, y-intercept, let 0 be x, 0, negative 3. There's your x, there's your y. Okay, give me a y. Negative 3. Give me an a. I don't know a, I'll just use a. The x value is going to be 0 minus 1 squared minus 5. Okay, order of operations. Let's square this first. Negative 1 squared is a positive 1. Let's add 5 to both sides. 2 equals 1a. Divide both sides by 1. Oh, that's silliness. So a equals 2. All right, that's great work, but don't forget you were supposed to write the quadratic function, write the equation. So f of x equals, the a value is 2. We're going to put that right there. We kind of had a lot of work already. X minus 1 squared minus 5. All right, I really want to see this graphed, and I want to see if that is the vertex and that ends up being the y-intercept. Please finish this graph because tomorrow I want to check. Thank you.